Okay, let's try this again. I'm going to talk about section 1.1, the distance and midpoint formulas. Let's say that you wanted to find the total distance between 2 points. Between 2 points, let's call them P1 and P2 in the coordinate plane. We can use the formula d for distance, which equals the square root of x1 minus, x2 minus x1 squared plus y2 minus y1 squared if the coordinates of P1 are x1 comma y1 and P2 are x2 comma y2. Now, why does this formula work? Well, it all depends on something we're pretty all familiar with, which is the Pythagorean theorem. I'm going to draw a picture of what something like this might look like. I'm going to put 2 points on my graph. Here's my coordinate plane. We'll call this point, coordinate x1 on the x-axis, this one x2, and then similarly we have coordinates on the y-axis, y1 and y2. So of course point P1 will be here with coordinates x1, y1, and P2 will be here with coordinates x2, y2. Here is a line segment, and I'm going to try to find the distance, or we can also call that the length of the line segment. We're going to call that d. Okay, now if we draw a dotted line here and here, we can create a right triangle. Right? Then when I look at the length of this side of the triangle, right? This has length x2 minus x1. Why? Well, let's take a look at this over on the side. Here's 0. If we just think of it as a number line, or maybe as a length of string, right? We know that the distance between 0 and x2 is equal to x2, right? If this were a number like 8, 0 to 8, the distance between 0 and 8 is 8. We also know that the distance between 0 and x1 is x1. So if we're looking for the distance between x1 and x2, right, we would take the entire distance, subtract or cut off the smaller distance of x1, and we would be left with x2 minus x1. So we could do a similar thing with the y's. Yeah. This distance here will be equal to y2 minus y1. Now let's take a look at our friend the Pythagorean theorem. The Pythagorean theorem tells us that if we take the square, the sum of the squares of the 2 legs, we get the square of the hypotenuse. So we have one leg, which is length x2 minus x1 long. We'll square that. We'll add it to y2 minus y1, which is the length of the other leg, squared. and that will equal our hypotenuse, which is d squared. Now solving for d, we end up with the square root of x2 minus x1 squared plus y2 minus y1 squared. And normally, if we were to solve an equation and put a square root sign on one side, we would have a plus or minus in front of it. But since distance is always positive, we can just use only the positive there. All right, so now we have our distance formula. Okay. Now to find the midpoint, of a line segment, with endpoints P1 and P2, we can use this formula. M for midpoint. Since the midpoint is a point, it's going to have x and y coordinates. We'll call them x and y. And so the x coordinate of the midpoint will be equal to x1 plus x2 divided by 2. And the y coordinate of the midpoint will be y1 plus y2 divided by 2. Again, when P1 has coordinates x1 comma y1, and P2 has coordinates x2 comma y2. So notice what's happening. We're taking the average of the x coordinates of both points, because we're adding x1 plus x2, dividing it by 2, and we're taking the average of the y coordinates of both points, because we're taking the y coordinates, y1 plus y2, and dividing that by y2. Why does this formula work? Well, let's draw a similar picture to what we did for the distance formula. Here's my y-axis, my x-axis. I'm going to put the same points, the same coordinates, x1 and x2 on the x-axis, y1 and y2 on the y-axis. We'll have P1 here with coordinates x1, comma y1, and P2 here with coordinates x2, y2. So I have a line segment, and then this time I'm going to be looking for the midpoint. Now the midpoint is going to be somewhere right in the middle, or exactly right in the middle, okay? And we're going to call it M. And remember that M is a point, so it has coordinates x and y. We'll just call them x and y right now. Okay, so because M has coordinates x and y, we know that we could call this here x, and this here y. Okay, and because it's midway between the 2 points, we know that the length here, which we can call x minus x1, and the length here, which we can call x2 minus x, oops, pardon me, let me erase that, are equal to each other, right? Because it's midway in between the 2 x coordinates of the 2 points. So I'm going to set x minus x1 equal to x2 minus x. Now if I go about moving some things around, I can add x to both sides. I get 2x. I can add x1 to both sides. So I'll get x1 plus x2. Then I can divide both sides by 2, and we're left with x equaling x1 plus x2 over 2. Right? Remember that that's exactly the x-coordinate of the midpoint, right here. Exactly. Yeah? We can do a similar thing for the y's. Yeah? I'm not going to do that. Now, using the distance formula and the midpoint formula is pretty simple. You just have to plug in values, the coordinates of your points, and do some calculations. There's lots of videos to watch on my math lab that will help you with this.